My name's John Gray. We're going to be talking about hybrid data lakes today. We're going to be talking about Cask and what we do and why we're so focused around that use case right now as what we see as pretty much the #1 use case in big data for enterprises. To me, it's the inevitable conclusion of the digital disruption, digital transformation, the whole data-driven movement. The data lake is the architecture that's going to actually support all of that. So my background really quick before we dive in. Founder and CEO of Cask. We've been at it for almost 6 years now. So I've been doing that for a while. Before that, I was at Facebook, where I did a lot of Hadoop and H-based stuff. Large, massive scale applications, both serving applications, analytical applications, things like that. And we had a data lake when I was there. We called it was HDFS and Hive. It was based, this is like 2010. And I got my start in Hadoop and HBase in 2007 when I had a different startup, and we were one of the early adopters of it. And so I've been dealing with the Hadoop stack and big data software since pretty much existed. And now, instead of focusing on internet companies, focusing on infrastructure innovation, myself and Cask, we've really tried to move up the stack to focus on what the enterprise problem is. Because it's a very different world outside of a company like Facebook, or my co-founder came from Yahoo. And there's obviously a lot of potential and opportunity and disruption in the technology, but it lacks accessibility for the many, many different things accessibility means. So hopefully what I can bring you through today is kind of my perspective and Cask's perspective on what a data lake is, what the point is, why a hybrid data lake or hybrid data lakes are, I think, inevitable, and then what Cask is doing to really address the different challenges that we see in the market. So for the first few minutes, let's define some terms, share some perspective. So what is a data lake? I've actually given this slide, I think, at this show at least once, maybe twice before. But it's always good to kind of level set. So at this show 7 years ago, James Dixon of Pentaho was the first person to kind of officially coin the term data lake, thinking about how data streams in from many different sources. You dive into the lake, all different types of users can come in. I think that the notion back then was much more experimental. I think today what you're seeing is the data lake is also potentially a grounds for production, and anything that has SLA, eventually, it is production. So the simplest ingest and ETL pipeline can be very, very critical. And so it's not just an experimentation playground when you're a large enterprise. Gartner takes a more enterprise-oriented approach, enterprise-wide data management platforms, analyzing different types of data from different places, basically in raw format. So they're kind of playing on the unstructured nature of it and all those types of things. Cloudera, they call this the enterprise data hub. Centralized, unified data source to provide diverse users with the information they need to do their jobs. More user-oriented and obviously unified. And Hortonworks talks about collecting everything, diving in, flexible access, maximum scale, lowest possible friction and cost. I really kind of think about it in these two ways. And when I'm thinking about this really from an enterprise perspective, the two major challenges are really about providing accessibility to users. So any user has self-service access to any data. Now, not every user should be able to see all data, right? And you need a tracking of what's happening to ensure that you can actually comply with security, policy, governance, things like that. And so to me, the pinnacle, the goal of the enterprise data lake is really to provide all that self-service access, but having security, policy, governance, auditability, manageability, and stuff completely out of view from those end users, taken care of. And so there's your lake, right? Lots and lots of different types of data sources. Traditional databases, more and more stuff we're seeing now in IoT data, machine data, log data, and cloud data. And so all that needs to come into the data lake. Obviously a huge focus around ingestion, the storage, and the compute layers. The whole point here is that it's fast, it's flexible, and it's scalable. And lastly, you need data governance and federation. And that's just essentially And then let me get to the roles here, sorry. And then there's all the users of this data lake. And that really, I think, becomes the whole point and the whole goal here, is that you have a lot of different skill sets, people using a lot of different tools, people that are familiar to a lot of different ways of looking at data, accessing data, analyzing data. And you can't move the entire world and all of these different users to different things. They're really comfortable with what they're doing, and they're trying to adopt the new things that come out. And so the goal of the data lake is really to give users access in their favorite tools and to simplify the experience of getting access to it as much as possible, such that it's not just data engineers and people like that who have to write codes or build ETL pipelines. It's an app developer who can go and type a few lines of code into a user interface and hit publish, or it's a data scientist who can scribble out some DSL instructions and create very complicated transformations or machine learning models, but very easily hand that over to production. Or a business analyst that's just trying to get some partition, some dump from 3 different databases and their SaaS applications, their CRM app, into somewhere so that they can do some BI on top of it. That's the whole point of the data lake, and that's really what we see as the point. So moving from the data lake now onto where the data lake lives, what the environment is. Today, we see in our large enterprise customers, historically, it's been very much on-premise. I'd say 2017 has been a very radical shift towards the cloud for the largest enterprises in the world. But if you look at 16 and prior, 90+% of the node count that we saw in our customer base was on-premise. So, well, obviously, there's the historic reasons why that all exists. There's performance reasons why that all exists. And there's going to be reasons why on-premise is always going to exist, right? I'm not going to spend a ton of time on this. We all know that cloud's a big deal and all this stuff. But just to kind of give an idea of why all these things, I believe, will exist. Obviously, there's the control, whether it's real or not. There's a very large array of very mature, very performant, very stable solutions in the market. So you can't just take very expensive and old systems that have been around for decades that do their jobs extraordinarily well and expect that AWS is going to launch an API that they developed for 6 months and it's going to just replace it. There is a lot of stuff a lot of innovation that has occurred on-premise that's still there. One of the benefits of doing this stuff yourself is you have a competitive advantage from building these muscles of doing it yourself. So if you actually take the pain to do it, it can become a competitive advantage. And obviously, from a cost perspective, you have a lot of upfront costs. There's not a lot of flexibility, but at scale, there's a lot of advantages to that. So cloud, to me, the real focus around cloud is the user. And I think if you look at how data lakes have evolved and what people think about them, more and more it is about the user. So it's really giving end users access, right? It's kind of like the SaaSification of enterprise, the consumerification of enterprise, right? There's a ton of new cloud-based services. And there's a lot of really interesting value from cloud-based services. And one of the first things that they do is they tend to collapse the stack. You have the user's interface and you have the cloud. And there's not a lot of layers in between. And so it provides a lot of usability to end users. And then obviously the pay-as-you-go, right? One thing I talk about as pay-as-you-go, and one thing I would talk about from the move of the Hadoop market and Hadoop users specifically on-prem to cloud is really the fact that in the cloud you can pay for compute and storage separately. And in Hadoop on-premise, you can't really pay for them separately, right? Typically you scale your clusters out at the same time. And so if you look at usability of clusters at internet companies, at enterprises especially, they're very, very underutilized typically, or wildly overutilized, right? Those are typically the two situations that you see. So what are the benefits of hybrid? So obviously you can optimize, right? You can choose what you want, where you want. You have way more flexibility in terms of workloads and where they can run and how much and how fast you can scale them. And so you just have way more knobs in a hybrid type of environment. I think, again, because of the collapsing of layers, which creates kind of this inherent simplicity, that you get more business agility. There's more of a focus around analytics rather than infrastructure. And that's a really good trend in the cloud. But obviously, you can cost optimize data and applications with the best of both worlds. I think I star that basically because it's really hard to do. I don't know how many people are effectively doing hybrid cost optimizations outside of very specific large-scale applications. But through companies like Cask and others, we certainly hope to deliver on that. So let me run through some challenges, because there's a few. So oftentimes when people are getting started building data lakes, there's a lot of manual work, there's a lot of coding, there's a lot of command line tools. Once you actually start populating that lake, it can be very hard to find data. You can maybe do a listing of your directory, see what your tables are, but there's not necessarily a lot of information like lineage and metadata and who accessed it, where did it come from. Also, when people initially build out data lakes, they're doing it with a specific use case or solution in mind. And oftentimes when you do that, the way you're getting the data in, the way the data is being processed, what ends up happening to that data, sometimes is built into a single solution. So now you don't really have an ingestion framework for your data lake. You have this one solution that kind of coupled these things together. Once you're maturing in your data lake journey, you have to operationalize everything, right? You have SLAs. You have teams that are going to get paged in the middle of the night if this partition doesn't show up in the table, because we are selling that data to a customer, and we've guaranteed in their contract that it should be there. Ensuring data is in canonical forms. This person has date of birth this way, that table has date of birth that way. This customer ID is 0 padded and that one's not. This is a long and that's an int and that's a string. Very typical kinds of problems, especially in Hadoop. And if you're not the person who's doing the manual coding, you might be a person who's filing a ticket or picking up the phone, tapping someone on the shoulder, and asking them to do it for you. In more mature organizations and people who have actually gone further and further down this journey, they run into problems like having multiple architectures. Different teams at different times for different applications use different tech. So they might have used different distributions, different NoSQL databases, different processing engines, different libraries, all kinds of different choices, which creates a lot of complexity downstream. Especially when you're doing something like guaranteeing compliance. So if everyone's using different frameworks for ingestion or storage or whatever it is, how are you supposed to guarantee some kind of compliance? And when you're in a system like Hadoop or cloud-based object storage, they're basically schema on read systems. So you can just put data in it without giving it any definition. So it doesn't exactly lead to the cleanest lakes. And then sharing infrastructure, and this has been a really big struggle on-premise for people. Sharing infrastructure is really hard in a multi-tenant environment without basically deep quality of service support all the way down the stack. And you don't really have that today in the Hadoop and big data market. So I'm going to talk about 3 reasons why I kind of look at the hybrid data lakes as inevitable. And what I'd say is, to me, it's really not just hybrid data lake. It's really just about this. The future of infrastructure and technology and data is going to be extraordinarily diverse. Like the edge was always this thing that we heard about, and IoT and blah, blah, blah. We actually have real customers now with real use cases who actually have edge applications. So it's actually coming right now. The time is now. And so we're dealing not just with how do I deal with having a giant data center and expandable public cloud. Well, how do I deal with 10,000 devices in the field? And how do I deal with all the data that they're emitting? And how do I deal with the fact that that data can be extraordinarily dirty? There can be so many different misalignments between the various driver versions, upgrades, and things that have happened out in the field. And so we see the edge is actually just making all of this even more complex, really driving towards, you need unifying layers is really the point. So the first one is the complexity, the heterogeneity, this diversity of environments, tech, skill sets, data. This is just the new normal. I'm an open source guy, and so I prescribe a lot of this actually from open source. Open source has driven tons and tons of innovation in technology, in software. And basically, it's a very different environment than we used to be in. You used to have very large megatech, Oracle, IBM, and Microsoft deciding basically what products were developed, and Gartner helping them to decide what the customers wanted, right? And today, you have Berkeley Amp Lab, who dropped Spark on the world, and all of a sudden every Hadoop company has to adopt it, build teams out and expertise in this project that they didn't choose, right? It just happened. So that's going to continue to happen in my mind, and this just rapid acceleration in innovation is just creating some chaos, but ultimately a lot of opportunity. So number 2, the flexibility and simplicity of the public cloud is not something that can be ignored. There's very clear immediate benefits, cost benefits, agility benefits, all kinds of benefits, and there's very clear long-term benefits. Over time, many of those benefits are just going to get better, right? They're commodities, they're going to get cheaper and cheaper over time, and so the benefits are only going to rise. And lastly, the importance and abundance of data is not going to slow down, it's going to increase. So data is going to be everywhere and needs to be accessed by everyone. So now we'll shift the discussion a little bit and talk about what we need to get there. We've spent 6 years trying to solve essentially this problem. And so I'll go into what Cask does, what our products are, and I should have time for a demo and questions. So what we need is an open source, enterprise-focused big data platform, which does 3 key things. So the first thing is that it integrates and standardizes infrastructure. So if you're in different environments, if you're using different technologies that are similar but not the same, of which there are many choices, basically you can go down the stack and there's an analog of so many different products, especially in public clouds, against AWS, Azure, Google, or MapR and Cloudera and Hortonworks, just name your choice, where there's basically analogs. So providing standardization and integration among all that is a really, really important part of how you're going to actually deliver on these hybrid, diverse environments. The second is this IT line of business gap. You need a lot of platform capabilities to deal with security and governance and scale and all those types of concerns. But this is really about the end users and giving them self-service access. And so you also need usability. The last is supporting the entire big data lifecycle, from how do I get the bits into the bucket to how do I serve them up to my report, my dashboard, my application, whatever it is. And so ingestion, data science, application development, production operations, management, all of that stuff really needs to be handled to be able to actually solve the end-to-end problem. So take a deep breath. I'm going to show you a diagram with a lot of boxes on it. This is the answer to all of your problems. It's CDAP, the Cask Data Application Platform. So this is an open source platform. You can go to GitHub and check it out. Everything actually you see on this page is open source. Everything starts with data in and can end with data out. At the bottom of our platform, we call it the portable production runtime environment. So essentially, there's a standardized layer for management, for operations, for security, for everything that is kind of a cross-cutting concern, so that you can run in any environment. So CDAP supports every Hadoop distribution. We support like 50-something different versions of Hadoop distros. We support all of the different cloud Hadoop distributions, and we also support the cloud-native services. So everything you build on top of the platform can be run in those different environments and integrated once into the rest of your enterprise. How you do your alerting, how you do your data governance, where you want your audit logs and your metrics to go. All of that gets unified against any of the environments and anything that you build on top of the platform. Functionally, it starts with data discovery. There's data preparation, data pipelines, data services. So how do I actually find the data? How do I actually explore metadata? How do I actually understand what that data is, where it came from? How do I interactively do data prep? People call wrangling. How do I operationalize my ingestion and processing pipelines, whether they're batch, real-time, machine learning, trivial ingest ETL pipelines? And how do I expose those back out, either as RESTful services or different types of microservices? On top of everything there's a metadata audit and lineage. So everything that you're doing is audited. All of it can be secured through authentication and authorization. There is lineage generated for all the interactions between data and programs. And we capture as much metadata as we can, and then allow you to set whatever metadata you want, business metadata, technical metadata. On top of all of those capabilities, which are exposed through RESTful APIs, there's UIs. So you never have to touch a command line, you never have to use the RESTful APIs, but you can when you want to and when you need to. But for a data scientist, for an end user, for someone who is just trying to point to one of these sources and get it in and read it into their BI tool, or they're playing with Python and TensorFlow and H2O, and they just need to get access into the data, or they want to take their Python code and deploy it into a Spark pipeline, that's what those UIs are all about. Today, historically, our customers have been on-premise. I'd say almost every single large customer, except for maybe a couple, have a hybrid strategy in mind, and maybe half of them, their goal is to be 100% cloud, 100% public cloud. Very large Fortune 500 types of companies. And then increasingly, we're seeing more and more of the edge. So people thinking about like 3 tiers now, not 2. So I'm going to take it down 1 level, and then we'll raise it back up. So the underpinning of CDAP is really this single set of abstractions. So we call them datasets, programs, applications. So all of your data, whether it's a Parquet file sitting in your local HDFS, or a Teradata table sitting in a remote data center, or an S3 bucket somewhere, everything can be represented as a dataset. So it's a logical representation that maps to its physical location. Programs are your code, like a Spark job, MapReduce job, a RESTful microservice. The platform is historically very Java-oriented, but in recent releases, we've supported more and more Python, more and more of the Python data science frameworks. And then everything can have metadata associated with it, and everything can be extended through plugins. And so this is the core architecture that really allows everything that's built on top of CDAP, like the data prep, the data pipelines, the data discovery, and all those things. They're all shared, and they can all swap things in between them, and you'll see it when I demo. And that's really because they sit on top of this kind of shared abstraction. And then this is what you map into your metadata systems, right? Your governing systems. This is what you apply security against, right? So you're not applying security against Spark jobs reading from HDFS files. It's programs reading from datasets. But Cask started with that core architecture like 6 years ago. And over these past 6 years, have really been focused on moving up the stack along with our customers. So we started out with this extensible, portable production runtime environment, security, governance, all those types of things built in. On top of that platform are our tools and frameworks. So these are things for common tasks, like discovery and ingestion, preparation. So it's no code, UI-driven, point-and-click type of user experiences. And then on top of that is our solutions and the Cask market. These are completed solutions. They either have interactive wizards, they might have their own dedicated UIs, as well as the pre-built apps, pre-built plugins, drivers, pipelines for doing common things, both publicly available, and you can have your own private markets as well. And so it's really been a focus on short-term business value, because that's something that we really see as critical to how we sell, how we make our customers successful in this very complicated, often wrought with failure space, is really to focus up and focus on delivering short-term business value. And as you do app 1, app 2, app 3, then you start to generalize, then you start to actually deliver on the vision of the enterprise data lake. But ultimately, starting with more specific solutions over more narrow things can be the best way to get started. So I'm going to provide a little comparison of how we think about CDAP versus what you would do without CDAP. So you're sitting on top of big data infrastructure, things like Hadoop, Spark, Kafka, clouds like AWS, Azure, and Google. They could be on-prem, public clouds, edge. And so think of this as the solution that you're building. So there's some amount of core work you're going to have to do to actually talk to those APIs directly. There's the common stuff that a lot of your different applications are going to have to do, and then there's the custom business logic for that specific use case or application. So typically, people DIY, right? You integrate the different components that you want to integrate, right? Whether it's a Hadoop distribution or a public cloud, you basically have a bag of APIs, right? Now you've got to weave these APIs together. So you weave them together, you do the common stuff and the custom stuff, and it's all this kind of tightly coupled solution. There's the tools route. Multiple tools, multiple vendors typically. So these tools are really taking care of dealing directly with the low-level APIs. They're doing some of the integration. They're doing some of the common tasks. you have to integrate the tools. If I do data prep in one tool and I do ingestion ETL when I operationalize it in another tool, if those tools can't talk to each other, somehow I have to actually integrate them. Oftentimes there might be a gap in a tool, or maybe I need to build my own little custom thing. So I might go down in that layer a little bit, and then I build my solution. And so you're definitely better off, but you might end up in like POC hell. You might end up with like 4 different vendors. You don't really know. And so that's why Cask's in the market. So I've been describing to you the platform that sits underneath it. This is the portable production runtime. There's this set of different frameworks that sit on top of it, and all the frameworks are kind of interchangeable and can exchange information. And then solutions get built up on top. Our frameworks are mostly open source as well. We have a few commercial enterprise ones, but many of our customers extend our frameworks. Many of the frameworks are built for extensibility, and also you can build your own frameworks. So let me go through some of those frameworks, and then we can jump into the demo here. So the first one is data prep. Probably seen different UIs like this. And basically, I'll do a demo for it, so I won't spend a lot of time here, and the same with the data pipelines. But basically, data prep allows you to connect to arbitrary data sources, do all types of parsing, wrangling, cleansing, and also rule validation. So you can actually do validation of this field should be no bigger than this value. If it isn't, then send it to an airport. You can then operationalize anything you do in data prep in the data pipelines UI. This runs on MapReduce Spark streaming, and allows arbitrarily complex DAGs. And I'll show a demo of that. Distributed Rules Engine is one of the newer frameworks that we've just delivered. And basically, it takes a lot of that stuff like, hey, if this value should be between this range, well, that's nice that you can do it that one time when you're doing prep. But how does like somebody who's actually managing the metadata repository or something enforce that type of rule? Like date of birth should always be in this format, and customer ID should always conform to this, and social security number should always be masked like this. So the distributed rules engine allows a non-technical user to actually write these rules out. You can even put them in a spreadsheet and import it from Excel. There's a metadata UI, so all of the metadata that we're capturing, any of the metadata that you put in there, that's all searchable. And you can see lineage, the audit log, all that stuff. I'll show that in the demo. Two of the more real-time, more IoT-oriented frameworks that we've developed recently, one is the microservices framework. You can think of this kind of like as a generic Lambda, AWS Lambda. You have a very, very generic API to define basically, API in, API out. And then it can be bound to these different channels. So I could say I want to pull from some MQTT and publish to Amazon SQS, and also write into an S3 bucket or something. ECA is actually part of that, built on top of that microservices framework, but it is a UI that allows people to essentially write like non-code oriented event condition actions. So for IoT applications, there's a lot of stuff like, let's say if the temperature of the room goes above 75 degrees, send this alert or do this action. A lot of IoT applications kind of come into that form. And so if you can make an interface and a dialect that's not too scary for non-technical users, they can actually crank out very complicated IoT logic. The Cask market sits at the top and basically has pre-built solutions. We have right now one third-party solution from Ericsson, who's developed a smart home IoT application. But in the future, we'll have more from third parties. But today, it's really around focused on getting people started, having access, point-and-click access to drivers to common databases, to doing things like data warehouse offloading and change data capture, doing things like cloud data migration. So like I mentioned before, covering the entire life cycle of data in the enterprise is really important, and kind of how CDAP is focused and why this collection of frameworks is what we have. You really, really start by onboarding data. It's the first thing you do in a data lake is onboarding data. So that's about prep. Now, you want to make sure that data conforms to what it should conform to. It should conform to policy, security, all of that type of stuff. Rules engine and CDAP help you with that. You then need to operationalize all of that. That's what you do in data pipelines. Eventually, you want to move from just doing ETL or just counting stuff to doing things like machine learning. And so you also be able to embed machine learning into your pipelines. Lastly, you're going to want to talk to your cloud applications. You're going to be able to run on the cloud, and you may want to start to integrate and actually migrate existing applications onto it. I'm going to go quick because I want to get to a demo. I got 10 minutes. So Cask and CDAP focus really around how we can help you with the hybrid data lake. Number one, prep to production. Right? So from the very first bit you're trying to pull from your first data source to how you would actually run that in production at scale with thousands of users accessing it, Cask has customers at all ends of those journeys. We have a big focus around self-service. So significant amounts of our R&D are completely focused around the self-service UIs and how we just further and further extend it into these different users who are trying to accomplish these different common tasks. And then the ability to secure and govern at scale. So things like namespacing, things like making sure that every single piece of data has an audit log around it, and providing authentication authorization in a very secured way, all really, really important to be able to get to the hybrid data lake. So really, really quick case study, Thomson Reuters, great customer of ours. We did a webinar. There's a case study available on our website, which I highly recommend to kind of understand how they're basically a data and content company at massive scale. And so they've done some really cool stuff themselves and with CDAP, essentially to cross this IT line of business gap. Before their content platform that they developed on top of CDAP and Hadoop, they basically had IT and data engineering doing all of the pipelines. So anytime a team said, hey, I want to take a look at this data asset that we have and that data asset that we have and sprinkle some natural language processing on top of it and generate this new data asset, they had to basically create a project, file a ticket, and have someone else do all the work for them. Now it's all in their own hands. So non-technical users get their own little view into CDAP and all our UIs. It's all pre-configured with all their different data sources for their organization, for that user. Everything's namespaced and isolated. So essentially, they have this kind of crafted user experience for everyone when they onboard them onto the data lake. They've been a customer for about 1.5 years now, I think. And basically, this is a very typical kind of adoption curve for a large enterprise using CDAP. You start developing applications immediately. And right about on the first anniversary, the first massive scale application, the kind of big juicy one we were targeting, goes into production. And then over the next 6-12 months, we see this kind of exponentially increase in the number of apps that get onboarded. So within 18 months, it's 80-something applications developed and 25 applications in production. And so that's really the point. Once it's been adopted and once it's there, you can move really, really, really quickly. So quick demo. Oh, shoot. Of course. I'm not mirroring my screen. There we go. OK, cool. So what I'm showing you is called the local sandbox. So in addition to supporting all these different distributed environments, like on-prem and cloud and hybrid, we also support slimmed down environments. And so next year, we'll be releasing our Edge. So it's actually a production slimmed down environment. This is really a development slimmed down environment. So it's a single process, runs on your laptop, supports basically every type of operating system, also supports Docker, and there's a VM. Or you can get a VM going in a public cloud, AWS and Azure. You hit a button in their marketplace, and you get your local sandbox. So everything you do here looks the same, whether you're on a 1,000-node cluster or you're on your laptop. I just created a little Strata namespace, so I had a new little space to do the demo here. Since we have like 5 minutes, I'll go pretty quickly. But basically what you see is anything that would be available. Any apps, programs, data, anything that you could see would show up here. So as we start to do stuff, so data preparation is the first framework that I'll show you, and this is typically the first thing that our users do. It starts with this notion of connections. So You can upload a file. You can go to your file system. So it points to whatever the file system would be. Here it's my local file system. If you're in the cloud, it would be, or if you're in a Hadoop cluster, it would be HDFS. In the next release, we will also have S3 and ADLS and things like that here. But today we have the file system. We have databases, arbitrary ODBC, JDBC databases, or Kafka. I'll just do a quick demo here. Grab this employees. I think it's CSV or JSON. So I got this employee file somebody sent me, and I want to bring it into my data lake. So we'll parse this as JSON. That will then explode it out. So we'll see we've got these different fields here. I'm going to remove this body prefix. Replace, remove body. I'll do a couple quick little things here, like title case, the first and last name. And I want to pull out the date, the year. Pull that out. We'll call this the year of joining. All right. So now we can see we have all this schema here. What I've been building up here is actually a list of what we call directives. So we have a DSL underneath data prep. It's about 1,500 different instructions today, and it's very easy for you to write your own. There's a UDD framework. So you just write against this very simple API, and you can have your own. And then there's like a power mode basically down here. So for things that aren't exposed in the UI, you can go down into this power mode. So these can be exported, imported just as text and reused anywhere. Built into this is also one of the newer features here, which is basically just looking at this local cached view in your browser. This isn't any server-side processing. And basically allows you to do some lightweight kind of just analysis, do some checking of the data, look for correlations and things like that. So like looking at your designation and the year that you joined, or how about your age? So you can see, for example, how old the CEO is, but the fact that vice presidents are all never younger than 45, right? And managers are never older than 55, and basically this actually looks like real data. So I think we don't have a bad data set here. So at this point, I could just go here and click ingest data, and what that would do is a one-time copy and either create a HDFS file set or a HBase table. Or I can operationalize this in either a real-time or a batch pipeline. So I'll do a batch pipeline and show real quick us loading this in with a Spark job. So this is our employee. We got 2 minutes. I'm going to finish. We've got our employee import. I'm going to write it out to a Parquet file. What you can see here in this Wrangler is those directives that I wrote. The schema is automatically carried over. If I wanted to make some kind of like change, let's say I want to actually not include the salaries. So we can jump back and forth. We can apply that. This will get updated. All the schema gets updated and propagated. And so then when I come in here, the schema is already here. I just give this my employee Parquet. Schema is all associated with it. You can preview it in your browser. You can set whether you want it to run as a Spark job or a MapReduce job, set resources, alerts, all that kind of stuff. This is a very flexible framework, so you can actually write Spark code in line as a transformation. You can import an existing jar that runs a Spark job unchanged and put it as a node in the pipeline. So there's a lot of different APIs. These are plugin APIs of how you can write stuff that just becomes a button in the UI. So at a company like Thomson Reuters, they have a big team of natural language processing machine learning people building a bunch of stuff in Spark. So they build out libraries of Spark functions that get automatically populated into people's user interfaces. So in your pipelines, you can automatically embed different types of NLP if you're a TR user, but you have no really idea about any of the science behind it, any of the technology behind it. It just becomes another icon. So then what I've generated here is actually a JSON of configuration. So I can run this right now, and I'll deploy it and run it really quickly. But basically, I could export this and now import it into my cluster. Or I could go and I could give it to IT to operationalize, or whatever the kind of life cycle would be at that company. So I'm going to go 1 minute over so I can show you the deploy. CDAP centralizes all your logs and metrics as well. So obviously this is all running on my laptop, so it's easy. But is this going to run? There it goes. It already ran. So you could configure this more. You can set it on a scheduler. CDAP has a built-in scheduler, a very complex one. So it does all kinds of things like partition awareness, repartitioning, making sure things don't overlap, all that kind of stuff. A lot of SLA management type of things. And then real quick, I'll just show you all the metadata that we captured from the work we just did. So if I go look at this employee parquet, sorry, created my own little namespace, so I need to turn the feature on in the namespace. So you get usage analytics, you get all the schema, you can see every program that's ever written to it. You automatically get a lineage graph, so you can select different time windows and basically see everything that's both left and right of it, so anything that populated it, what the jobs were. You can drill down and actually see the specific run IDs, go and drill down into the logs. You get an audit log. Now, everything in this UI is built on top of public available REST APIs. So it's very easy, for example, to take all this metadata, all these audits, put them into other systems. And they're also available on Kafka queues. And then you get properties, basically key value metadata and tag metadata. All the data sets have SQL access. So we create Hive tables. It's exposed through ODBC drivers and libraries and SDKs. And there's a bunch of other cool stuff that I didn't have time to show you. So I would highly recommend you come by the Cask booth. We're booth 343. Get some really cool swag that we have. I think they're going to get you on the way out. And also see more of a customized deep demo if you're interested. Thank you.